Okay, so we're going to do 19.16 and 17. So it's basically a practical or an application of the cartel agreement that we were doing a bit earlier. Okay, so it's basically having two firms in the market, and the two firms trying to engage in a cartel agreement where they basically, like I said before, acting as one firm, as a monopoly, to try to reduce the level of output in order to increase the price and increase the firm's profit. Okay, so we are given a demand function P equal to 270 minus Q. Each of the firm is having a marginal cost of 30. So 19.16 asking you, suppose that there is no cartel agreement and we try to obtain a Conant-Nash equilibrium, calculate a profit for each of the firm. All right, so if the two firms are not trying to do any agreement, are not trying to cooperate with each other, and they are competing in a Conant-Nash equilibrium, then what is going to be the output that each of the firm is going to produce, and what is going to be the firm's profit? Okay, so okay, I would let Q1 okay be the quantity produced by firm 1. Okay, and Q2 be the quantity produced by firm 2. Right, so the Conant-Nash equilibrium is basically the equilibrium in which the two firms are competing on quantity. Okay, so basically they are choosing the quantity separately, simultaneously at the same time in order to maximize their own profit. Okay, so they're competing on quantity. Okay, so this is called a Conant equilibrium. Right, so each of the firm is going to choose Q1 and Q2 to maximize the firm's profit. So we know the total output in the economy Q is just going to be Q1 plus Q2. Okay, there's only two firms in the market. All right, so so we are going to write out a profit for firm 1 first. So I'll call that is pi 1, and that equal to total revenue 1 minus total cost 1. Okay, so total revenue is just the price in the market times the quantity Q1, and total cost again is just the average cost for firm 1 times Q1. Again, because we have a constant marginal cost, so average cost is going to be equal to the marginal cost. And so therefore it's going to be equal to P minus AC1 times Q1, okay? And so therefore it's going to be equal to P minus C1, Q1, okay? In this case, AC1, average cost is just going to be equal to the constant marginal cost equal to C1, all right? And so we have P is 270. And minus big Q over here, all right? Now big Q is just basically Q1 plus Q2, so I substitute that into here. All right, so I got Q1, okay, plus Q2, so I got minus in front, so that's become minus Q2. So that is my price, okay? So the whole thing over here is just the price. And minus C1, everything times Q1. So now I just got C1 is equal to 30, and so that will be, so if I substitute that into here, then I got 240 minus Q1 minus Q2 and everything times Q1, so that gives me 240 Q1, okay, minus Q1 square minus Q1 Q2. Right, so that's the profit for firm 1. So we're going to do exactly the same thing for firm 2 by writing that as profit for firm 2. Okay, so or maybe before we go into firm 2, we'll try to finish with firm 1 first. Now, so what firm 1 wants to do is to try to maximize firm's 1 profit by choosing the quantity. Okay. Q1. All right, so therefore what we do is we try to find a first order condition where we differentiate the profit function with respect to Q1 and make it equal to 0. Okay, so remember, firm 1 is only choosing Q1. It has no control over Q2. Okay, so Q2 over here is basically treated as a constant for firm 1. Okay, so when we're dealing with firm 1, where firm 1 is trying to pick Q1 to maximize firm 1's profit, it has nothing to do with Q2. Okay, so when you differentiate this, you'll get 240 minus 2Q1, and over here we're treating Q2 as constant, so that becomes negative Q2. Okay, and we make it equal to 0. So if we rearrange this to make to find the value of Q1, we get 2Q1 equal to 240 minus Q2, and so therefore Q1 is 120 minus half of Q2. Okay, so this is called the best response function for firm 1. So it's basically the quantity chosen by firm 1 given the quantity chosen by firm 2. So depending on how much firm 2 is choosing over here Q2, this is the best response function for firm 1. This is how much firm 1 is going to produce to maximize firm 1's profit. Okay, so we are going to do exactly the same thing for firm 2. We write that a profit for firm 2, which is again just the total revenue minus total cost. And again, that's just going to be the price minus C2, everything times Q2. Okay, and again, the price is just given by the demand function, 270 minus Q1 minus Q2. And C, the marginal cost of firm 2 is again is $30. Q2, so that will just give me 240 minus Q1 minus Q2 times Q2. And so that is 240 Q2 minus Q1 Q2 minus Q2 squared. So again, firm 2 will try to maximize firm 2's profit by choosing Q2. Okay. Again, firm 2 is having no control over Q1. So we're just treating that as constant. Okay, so we maximize. So we differentiate the profit with respect to Q2, make it equal to 0. We get 240 minus Q1 minus 2Q2. Okay, so over here we are treating Q1 as constant, and we make that equal to 0. So again, we find out 2Q2 equal to 240 minus Q1, so therefore Q2 is 120 minus half of Q1. So I'll call this is the first equation, this is the second equation. Okay, again, this is called the best response function for firm 2. All right, so now we got two equations, two variables, Q1 and Q2. You should be able to find a value of Q1 and Q2 that is maximizing firm 1 and firm 2's profits. Okay, so we combine the 1 and 2 together. So if I substitute 1 into another, so if I substitute, say, 2 into 1, if you want to substitute 1 into 2, that is totally fine. Okay, so I get Q1 is 120 minus half of Q2, and Q2 is given by the second equation, which is 120 minus half of Q1. Okay, so if I expand this, I get 120 minus half of 120 is 60, minus become plus, half times a half is a quarter of Q1. Okay, so if I move this quarter Q1 to the left hand side, Q1 minus quarter Q1 is 3/4 Q1, and that 120 minus 60 is 60. Okay, so solving this equation, I get Q1 is so 60 times 4 is 240, 80. Okay, so this is the optimal quantity produced by firm 1 in order to maximize firm 1's profit. Okay, and so if I substitute Q1 star into the second equation, then I'll get Q2 star is 120 minus half of Q1 star. So 120 minus half of 80, which is 40, so that's 80 as well. Okay, so therefore the quotient Nash equilibrium is basically for the two firms to produce 80 units of output each. Okay, so Q1 equal to 80, Q2 equal to 80. Okay, so what is the profit for the firm in each of the case? So easiest way is we just substitute the value of Q1 star and Q2 star into the profit function, pi 1 and pi 2. Okay, so I got pi 1 is, so we're looking back at pi 1 over here. So this is the equation for the profit. Okay. So if you want to use that, that is fine. Or if you want to just find the price. So I got Q1, Q2 is here. So therefore the market price P is 270 minus the total quantity, which is Q1, Q2. So 270 minus 80 minus another 80, which is 160. So that is 110. Okay. Okay, so the profit for the firm is up to you. Okay, so if you want to substitute back into the profit function we got earlier, that is totally fine as well. So I got the profit for firm 1 is just the price, 110, minus the cost, which is 30, and multiply by the quantity Q1, which is 80. Okay, so that is 80 squared, which is 6,400. Okay, very similar for firm 2. The price is the same, 110. Cost is the same, 30, and the quantity produced is the same, which is 80. So the profit is the same. Okay, so each of the firm is earning 6,400 under the Cournot-Nash equilibrium.